In the previous video, we saw how to convert phasors between polar form and rectangular form. And basically we did this by hand by working from the phasor diagram. But it happens that most scientific calculators have the capability to perform this conversion automatically. Now, it's going to vary depending on the type of calculator you have. And of course, I cannot tell you how it's going to be on all calculators. But on the Casio, my little Casio, there is a button marked Paul right here, which is used to convert from rectangular to polar. And then also there's a second function on this key marked REC will convert from polar to rectangular. Okay, so let's see how to do this. Suppose that we need to, going back to that example we looked at in the previous video, where we had to convert 5 plus J3 to polar form. And we go Paul, and then 5 comma 3, and then equals on the little Casio. Okay, so here we go. Paul, and it already puts the parenthesis in, and then 5, and then comma 3. That comma is important. And then press equals, and we get the 5.83, which, as you remember, was the answer that we got for R in working it out by hand. So now the question is, how do we get the angle out of this? And on my Casio, the way you have to do that is recall alpha F. And so that gives us the angle in degrees, 30.96. That was the answer that we got when we did it by hand. I rounded it off to 31 degrees. Okay, so once again, this is how we do it on the Casio. On your calculator, it may be different. Okay, now let's review the second example that we looked at, converting 5 at 36.87 degrees to rectangular. Okay, on the Casio, we're going to use the REC, which we get by going Shift Paul, and then 5 comma 36.87. So here we go. Rec 5 comma 36.87 equals. Okay, and what we get out of this is the X value. So 3.9994, close enough. And again, in order to get the Y value, we need to go recall alpha F. And there's the Y value. And so the answer is 4 plus J3. Now on the TI-83, I don't have a TI-83 handy to demonstrate this, But in order to do this conversion on the TI-83, you would need to go to the angle menu, and there are 4 options in the angle menu which relate to what we're talking about. R to PR converts from rectangular to polar and gives you the R value. R to P theta converts from rectangular to polar and gives you the angle value. Okay, so that means you'd have to do 2 conversions, angle 5 and angle 6, in order to get both R and theta values. And going back the other way, if you do P to RX, that will convert from polar to rectangular and give you the X value. And then P to RY will convert from polar to rectangular and give you the Y value. Okay, so let's do an example or two. We're given VR equals 4.3 volts and VC is equal to 6.1 volts. Find the magnitude of the excitation and the phase angle. Okay, so we know that VR and VC are related as legs on the right triangle. And so this basically amounts to a rectangular to polar conversion. So we need to do Paul, and then 4.3 comma 6.1. Okay, so that gives 7.46 for E, and then recall alpha F for theta, 54.8 degrees. Okay, there's the circuit diagram. And there is a negative sign, and of course that's by convention because capacitors' voltage lag the current. But as I mentioned before, I'm not going to be too concerned about the sign of the phase angle. Okay, now let's do an inductive problem. We have VR and VL. 6.2 for VR, 3.8 for VL. So we need to do Paul. 6.2, comma 3.8. 7.27 for magnitude of E. And the phase angle 31.5 degrees. Okay, now let's work with impedance. Example C, we have 14 kiloohms and for the resistance and 11 kiloohms for the reactance. We want to find impedance and the phase angle. So again, this is a rectangular to polar conversion. So I need to go Paul, 14, comma 11. Value of the impedance is 17.8. Recall alpha F. Phase angle 31.2 degrees, 38.2 degrees, approximately.